Hello everyone, Namaskar, Rajkrishna this side. So let's solve one more problem from finding a polynomial from set of values. So it is given that the find the unique polynomial p of x of degree 2 such that value of polynomial at 1 is 1, value of polynomial at 3 is 27, value of polynomial at 4 is 64. It's a polynomial in x, so for x naught equals to 1, your f of x naught is given as 1. For x naught equals to 3, your f of x naught is given as 27. For x naught equals to 4, your f of x naught is given as 64. As you can see, the interval is unequal. After 1 we are going to 3 and then 1 unit to the right is 4, so it is unequal. So we can use different method, but one such is the Lagrange's interpolation method. So let's first write the standard formula for that. So Lagrange's interpolation formula. So if we want to find p of x, what we do in the first term, in numerator we don't write x naught. So what is left? x1 and x2 is left. In denominator, just replace x in numerator by x naught and write it as it is. So x naught minus x1 will be there and x naught minus x2 will be. And what x naught was left, you write this like this, f of x. Okay. So first term we made, in numerator we didn't write x naught. Similarly, in the second term, in numerator we will not write x1. So x minus x naught will be there and x minus x2 will be there. And x1 minus x naught will be there, x1 minus x2 will be there, and f of x1 will be. Similarly, for the third term, you don't write x2, you write x minus x naught, x minus x1, and x2 minus x naught, x2 minus x1, x2 you left, write like this, f of x2. Now this was the standard formula. Let's apply this for the given problem. So we'll get polynomial in x as, what is the value of, here it will be x1, x2. F of x naught, here it is x1, f of x1, x2 and f of x2. Okay, a big mistake was there. I hope you would have corrected it. So x minus x1, that means x minus 3, x minus x2 means x minus 4. In denominator, x naught, which is 1, minus x1, which is 3, x naught, which is 1, minus x2, which is 4. F of x naught is 1, plus x minus x naught, x minus x2, x1 minus x naught, x1 minus x2, f of x1, then we have x minus x naught, x minus x1, x2 minus x0, x2. This is just 4, not 64. x2 minus x0 and x2, which is 4 minus x1, which is 3. I hope I have written the values correctly. Let's move forward. Now, this px is, let's open this as a quadratic, it will open. So x square minus 4x minus 3x, so minus 7x plus 12. In denominator, negative 2, negative 3, that will give you 6. Here 3 minus 1 is 2, 3 minus 4 is minus 1. So minus 27 by 2 as a constant. And what about quadratic? That is x square minus 4x minus x, so minus 5x plus 4. 4 minus 1 is 3, 4 minus 3 is 1, so simply 1 by, okay, f of x2 is to be multiplied, which is 64. So 64 by 3. Again, quadratic will be x square minus 3x minus x, so minus 4x plus 3. Let's simplify this. So let's take 6 as the LCM. You will be left with x square minus 7x plus 12 minus 54, because it will be multiplied by 3, so 81, sorry. Times second quadratic. And twice, that means 128 times the third quadratic. So your polynomial in x will be, let's collect the like terms. X square will be 128. Let's use calculator so that it will be faster, because it is allowed in most of the cases. So x square coefficient is 1 minus 81 plus 128, so that is 48. X coefficient is minus 7 plus 405 and 480 and 32, 512. We'll have to check this once again. 128 into 4 is 512. So negative of 512 plus of 405 and minus of 7. So minus of 114. And the constant terms are 12 minus 324 and plus 384. So 72. So polynomial in x will be, this will be 8x square and this is 114 divided by 6 will give you 19, and this is 12, so plus 12. So this is the polynomial in x which we were looking for. Okay, so if you look at this polynomial and want to recheck it, then let's recheck. If you put 1, this is going to give you 8 minus 19 plus 12, which is 20 minus 19, which is 1. If you put 2, I think 2 was not there, 3. If you put 3, so 8 into 3 squared, that is 72 minus 57 plus 12. So this is 84 minus 57. 20. Oh, this is 7, so 27. Again fine. If you check at 4, so this is 4 square is 16, 128 minus 76 plus 12. So this is 140 minus 76, so that is 4 and 24 and 64. Again fine. So all the three values are matching. This is only we can do in exam because we don't have the solution right in front of us, so we can check for the values. This is a very good property of this type of problem, that you can check your answer right there. So again, we can use different method, but we use the Lagrange interpolation formula to solve this problem. We had the values, we put that and simplified it to get our required quadratic polynomial. So that's it for today. You can watch out such more problems in the playlist Iterative Techniques and Interpolation. Thanks again.